Let us study the elastic behavior of solids. What do you mean by a rigid body? A rigid body generally means a hard solid object having a definite shape and size. But bodies can be stretched, compressed, and bent by applying large force. So solid bodies are not perfect. When you stretch a solid body like a helical spring, its shape and size changes. When you release the ends of the spring, it regains its original shape and size. Same thing happens when you stretch a rubber band and release it. So the property of a solid body by virtue of which it tends to regain its original shape and size when the applied force is removed is known as elasticity. The materials possessing elasticity are known as elastic materials. When force is applied on an elastic body, it gets deformed. So, the deformation caused in an elastic material when an external force is applied on it is called elastic deformation. This deformation is due to the atomic structure of elastic materials. This is the structure of an elastic body. Each atom or molecule is surrounded by neighboring atoms or molecules. These atoms are bounded by interatomic or intermolecular forces and stay in a stable equilibrium. This arrangement is similar to a spring ball system. The balls represents the atoms and the spring represents the interatomic or intermolecular forces. Now displace the ball in spring ball model. When the external force is removed, the ball comes back to original position. That is, the spring system tries to restore the ball back to its original position. Similarly, in elastic bodies, when the applied force is removed, the interatomic forces tend to drive atoms back to their original position. But all solid bodies are not elastic. When you apply force on cement or clay, its shape changes and it does not regain its original shape and size even after removing the applied force. So the property of not regaining the original shape and size and deforming permanently is known as plasticity. The materials possessing the property of plasticity are known as plastics. Stress and strain. When a stretched spring is released, it comes back to its original shape and size. Similarly, when we compress the spring and released, it comes back to its original shape and size. In both the cases, the characteristic property of elastic material is acting, which is known as the restoring force. It helps the elastic materials regain their original shape and size. When we stretch the spring, the deforming force will act in the outward direction and the restoring force will act in the opposite direction, that is in the inward direction. Similarly, when we compress the spring, the deforming force will act in the inward direction and the restoring force will act in the outward direction. So, the restoring force will always be equal in magnitude and opposite in direction of the deforming force. The restoring force per unit area is known as stress. For example, if a force of magnitude F is applied to a body of cross-sectional area A, then stress equal to F by A. SI unit of stress Newton per meter square or Pascal. Dimensional formula ml raised to minus 1 T raised to minus 2. When you apply stress, dimension of body changes. So, ratio of change in dimension to the original dimension is known as strain. Strain has no units. Hooke's law. The mathematical relation for stress and strain was given by an English physicist, Robert Hooke. He performed experiments on springs and found that elongation produced on a body is proportional to the applied force. He presented his law in 1676, which is known as Hooke's law. It states that strain in a solid is proportional to the applied stress within the elastic limit of that solid. Mathematically, Hooke's law is represented as stress proportional to strain or stress equal to K into strain, where K is known as modulus of elasticity. Thank you.